This example is number 41 in 10.2. So I've got that in a document so that we can look at it a little bit bigger. And we're going to type into this. So first thing is pause and read the question and make sure you're comfortable with what it's asking. So in these questions, you really want to make sure you understand what the variables are. So if you haven't reread it a couple times, make sure that you're comfortable with what the experiment actually is. So they've got this control group that is relying on a more natural food supply. And you can see based on the data that's here that that control group, which is sort of the natural supply, the birds fed them a little bit earlier. So it looks like they may have learned from one year to the next. The supplemented group fed later. So it looks like they may not have necessarily learned from that year's experience. So we're going to be looking at the difference. So is that average significant enough to confirm the belief of the researchers? So let's type that out. So we'll get our mu1, and what we want to know is this difference? And I guess what we should really do is make sure we define our null hypothesis. Is our mu1 and our mu2, is that greater than 0? Or sorry, the null hypothesis is that there's no difference. The alternate hypothesis is that there would be a difference. So in that case, this difference is, well, in our case, less than 0, because we're looking to see, is the control group really less enough versus the supplemented group? And we want to define what our variables are, so just make sure that either you define it in one big sentence for mu1 minus mu2, or you just define one and then the other. So that's how I'm going to do it here. So our first one is the number of days, or the mean number of days after, now let's just read this to be sure. So after caterpillar peak that they produce their nestlings. So mean number of days after caterpillar peak the birds produced nestlings. And this is with the control group. Now our mu2 is the same exact thing except with the supplemented food or supplemented caterpillars or that kind of thing. So let's move on from here. So because we don't have a population standard deviation, we are going to be using a t-test here. So it's going to be a 2-sample t-test where we are just looking for a difference between those samples. So that's what we're looking for here. So I'm just going to write that down, 2-sample t-test, and we've defined everything that we need to up here. So what I'm going to do now is state my conditions. Is randomness stated, first of all? So now if I look up in the example, the random assignment is mentioned here. So we have that. Are we sampling less than 10% of the population? So we assume that the 13 birds here are less than 10% of the entire population of birds. So we're going to assume that that condition is met. But in reality, we actually don't have to do the 10% condition in this case because we're doing a paired test and all of the subjects were randomly assigned. So in this case, looking at one sample versus the other, you don't necessarily have to do that condition, so I don't even have to state that. Now, I do need to make sure that the shape is not totally skewed or something like that. Now, it's a really small sample size, so we'll go to the stem plot, and I've already put this into the calculator just to save a little bit of time. So I've got my plot 1 and plot 2 on. I'm going to take a look and see what these look like. So they look fairly symmetric. I do see that this tail's a little bit longer, but the only time you're going to reject a t-test in this case is if there's really strong skew, no symmetry, anything like that. So our shape is of each sampling distribution, or of each sample, is symmetric, and there is no strong skewness. So we're going to proceed with the T procedures. So I'm going to go ahead and run my test. So I'll go to stat, I'll go to test, I'm going to do a 2-sample t-test, and the data is input, list 1, list 2. Now my comparison here, mu1 is going to be less than mu2. I'm looking to see if it's significantly less. And I'll go ahead and calculate it. Now remember that if you're using the calculator, you really want to write out most of what the statistics are here. So I'm going to go ahead and do that. So my t statistic, or my sample statistic, is equal to negative 3.73. 739. I've got a p-value which is real small, so we can already tell we're going to reject the null hypothesis. My degrees of freedom, you want to make sure you state that 10.95. I've got my 2 samples, so I've got my sample mean here. So actually we're going to have to insert an equation to get our little bar. So our first sample mean, I'm still in the subscript, is 4, and my other sample mean for my second one is 11.3. My sample standard deviation, I've got 3.1093. Let's make sure we note that as a 1, and I've got my second one, 3.9256. Now, the other part of each sample size is not really necessary to state. So at this point, I can go ahead and make my conclusion. So I've got enough information to do that. So I can say, now there was no, you're always just assuming an alpha level of 0.05 if it's not stated, which it's not in this case. So because our p-value, 0.00164, is less than the alpha value, let's get a nice looking alpha. We reject the null hypothesis. And I'm just going to go ahead and restate the null hypothesis. Now, you don't even have to say the words null hypothesis in this case, because you can just say we reject the null hypothesis that it's equal to 0. There is significant statistical evidence to suggest the mean number of days the birds, can't type, produce nestlings is fewer in the control group versus the supplemental food group. That's basically it. So you've put it in context, you've made the right rejection, and you're good to go. Now, the second part of the question here asks us to interpret the p-value from part A. So this basically is stating if the test, or the p-value, which is 0.00164, is the probability that this happens by random chance, basically. That the difference, now our difference is 11.3 and 4. Now if I subtract those, because that's literally what the subtraction part here is. So if you actually do that out, which is 4 minus 11.3, which is equal to negative 5.3, or sorry, negative 7.3. and this is days, occurs by the random chance associated with random sampling. So that or more is the difference, really, what it's talking about. This difference, negative 7.3 days, occurs by random chance associated with random sampling. So it's really this or more. So this negative 7.3 days or more occurs by random chance associated with random sampling. So it's a really small chance, is basically what this is saying. So I hope that helps.